How does Wi-Fi actually work? Right now, wherever you are, you're probably surrounded by something completely invisible. No, not ghosts. We're talking about Wi-Fi signals. Think about this for a second. You're watching videos, sending messages, downloading files, and browsing the internet without a single wire connected to your device. So how does that actually work? Imagine standing in a giant room filled with people. Instead of walking over to someone to deliver a message, you simply shout it across the room. Wi-Fi works in a surprisingly similar way. Your router acts like a tiny radio station. It constantly broadcasts information using radio waves, which travel through the air at nearly the speed of light. Your phone, laptop, gaming console, and smart TV all contain miniature radio receivers that listen for these signals. When you search for a video online, your phone sends a wireless signal to your router. The router contacts your internet provider, retrieves the information, and sends it back to your device. The truly crazy part? Modern Wi-Fi networks can transfer billions of pieces of information every second, while dozens of devices communicate simultaneously, which means your house is probably filled with invisible conversations happening right now. And somehow, that's only the beginning. How does GPS know exactly where you are? GPS feels like magic. You can stand in the middle of a forest, a desert, or the middle of nowhere, pull out your phone, and somehow it knows your exact location. The answer is orbiting above your head. Dozens of GPS satellites constantly circle Earth. Each satellite continuously broadcasts two things: its exact position and the exact time. Your phone listens to several satellites at once and calculates how long each signal took to arrive. Imagine someone tells you you're exactly 10 miles away from one city. That still leaves millions of possible locations. Now imagine they tell you you're 15 miles from another city. Your possible location becomes much smaller. Add a third reference point, and suddenly your location becomes incredibly precise. That's exactly how GPS works. But here's where things become absolutely insane. GPS only works because Albert Einstein was correct about relativity. Because satellites travel extremely fast and experience slightly weaker gravity than we do on Earth, time actually moves differently for them. Without correcting for Einstein's calculations, GPS systems would become inaccurate by several miles every single day. So every time you use Google Maps, you're secretly relying on one of the greatest scientific discoveries in history. And somehow, your microwave might be just as impressive. How do microwaves heat food so fast? Most people think microwaves cook food from the inside out. That's actually a myth. Microwaves generate a special type of electromagnetic radiation that interacts incredibly well with water molecules. And water molecules have a strange property. They have tiny positive and negative ends. When microwave radiation hits them, they begin rotating back and forth billions of times every second. Imagine rubbing your hands together as quickly as possible. Eventually, friction creates heat. Now imagine trillions upon trillions of molecules doing that simultaneously. That's basically what's happening inside your microwave. The microwave itself doesn't create heat. Instead, it forces your food's own molecules to generate heat through movement. That's why soup heats faster than bread, and why sometimes the plate stays cool while your food becomes unbelievably hot. But if that's surprising, your smartphone screen is doing something equally incredible. How do touchscreens know where you touch? Every day, you tap, swipe, scroll, and pinch your phone screen. But how does a piece of glass know exactly where your finger is? The answer is electricity. Under your phone's glass is a nearly invisible electrical grid, and your body naturally conducts electricity. The moment your finger touches the screen, it slightly disrupts the electrical field at that exact location. Thousands of sensors instantly detect this change and calculate your touch position. This process happens so quickly that your brain perceives it as instantaneous. This is also why normal gloves don't work on smartphones. They block the electrical interaction. Special touchscreen gloves work because they contain conductive materials that imitate your skin, which means every swipe you've ever made was really just your body interfering with an invisible electrical field. And speaking of invisible things, let's talk about sound itself. How do noise-canceling headphones remove sound? This one sounds impossible. How can headphones remove sounds that already exist? The answer involves one of the coolest tricks in physics. Sound travels in waves. And if two opposite waves collide perfectly, they cancel each other out. Imagine pushing someone on a swing. Now imagine another person pushes in the exact opposite direction at the exact same moment. The swing stops moving. Noise-canceling headphones do exactly that. Tiny microphones listen to the sounds around you. Their processors instantly create opposite sound waves and play them through the speakers. When the two sound waves meet, They cancel each other. That's why airplane engines suddenly disappear. Air conditioners become silent. Train noise fades away. Your headphones literally fight sound with more sound. And yet somehow, that's not even the strangest thing on this list. Why is ice so slippery? Most people think ice is slippery because it's smooth. Not exactly. Scientists discovered that the outer layer of ice behaves differently from the solid ice beneath it. The molecules at the surface aren't completely locked in place. Instead, they form an incredibly thin layer that behaves almost like liquid water. When you walk on ice, you're actually sliding across this microscopic layer. Without this strange property, ice skating might not even exist, which means one unusual characteristic of water molecules helped create an entire Olympic sport. But speaking of misconceptions, here's another one. Your refrigerator doesn't actually create cold. How does a refrigerator keep things cold? This sounds impossible, but it's true. Your refrigerator never creates cold. Instead, it removes heat. Inside your refrigerator is a chemical called refrigerant. This chemical constantly changes between liquid and gas. When it evaporates, it absorbs heat from inside the refrigerator. Then it travels to coils outside the fridge, where it's compressed and releases that heat into the room. Then the cycle repeats. That's why the back of your refrigerator feels warm. The heat didn't disappear. It simply moved somewhere else. In fact, if you left your refrigerator door open forever inside a sealed room, the room would eventually become hotter. And somehow, humans figured out something even more impressive: flying. How do airplanes stay in the air? A passenger airplane can weigh hundreds of tons. So why doesn't it simply fall out of the sky? The answer lies in the wings. As air flows around an airplane wing, pressure becomes lower above it and higher below it. This pressure difference creates lift. But that's only part of the story. The wings also push enormous amounts of air downward. According to Newton's laws, pushing air downward creates an equal force upward. Together, these forces allow airplanes to fly. It's one of the greatest engineering achievements in human history. And somehow, we've made it so common that we complain when our flight snacks aren't good enough. But perhaps the most misunderstood technology of all is something millions of people use every day: the cloud. What is the cloud? When people say their files are stored in the cloud, it sounds futuristic. But the reality is surprisingly simple. The cloud is just someone else's computer, actually thousands of computers. When you upload a photo, it gets copied to giant data centers filled with enormous numbers of servers. Some of these facilities consume enough electricity to power entire cities. Your files are usually copied multiple times in multiple locations, so they aren't lost if one system fails. So, when someone says, "My photos are stored in the cloud," what they really mean is, "My files are sitting in a giant warehouse full of computers somewhere on Earth." But here's a question that's confused people for centuries. Why do mirrors reverse left and right? Why don't mirrors actually reverse left and right? Here's the strange truth. Mirrors don't reverse left and right. They reverse front and back. If you raise your right hand, your reflection appears to raise its left hand. But that's because your brain imagines rotating the reflected person around. In reality, mirrors simply reverse depth. They turn toward the mirror into away from the mirror. Your brain creates the illusion that left and right have switched. It's one of the best examples of how human perception can trick us. And speaking of things that only exist because humans collectively agree they do, let's talk about money. How does digital money work? Here's something weird. Most money on Earth doesn't physically exist. When you tap your card to buy something, no actual money moves anywhere. Instead, computers update records. One number decreases, another number increases. That's it. Modern economies operate largely because billions of people agree that these digital records represent value: your salary, your savings, your investments. Most of them exist only as information stored inside computers, which makes money one of humanity's largest collective agreements. And finally, we arrive at perhaps the greatest mystery of all: your own brain. Why do we dream? Every night, your brain creates entire worlds, and scientists still don't fully understand why. Some researchers believe dreams help process memories. Others think dreams regulate emotions. Some suggest dreams help us practice surviving dangerous situations. During REM sleep, the emotional and visual parts of your brain become highly active, while logical areas become less active. That's why dreams often feel vivid, emotional, and completely bizarre. In a way, every night your brain becomes the writer, director, actor, and audience of its own movie. And perhaps that's the most incredible thing of all. The truth is, the more we understand ordinary life, the less ordinary it becomes. Invisible signals surround us. Satellites depend on Einstein. Machines destroy sound using more sound. Your refrigerator moves heat. And every night, your brain creates entire realities while you sleep. The world has always been extraordinary. We just don't notice it anymore. Thanks for watching, and I'll see you in the next video.